Hoy, en Toquin TEC, Valeria Bosio se encuentra con el ganador del Premio Nobel de Medicina de 2017, Michael Rosbash, para explicarnos cómo funciona nuestro reloj biológico y repasar su vida personal y laboral.
Professor Michael Rosbash, very welcome to Argentina.
Gracias, un placer para mí.
Estoy sorprendida. ¿Habla español entonces?
Un poquito.
Un poquito. Usted fue premiado recientemente con el Premio Nobel a Medicina por sus estudios en todo lo que tiene que ver con la regulación del ciclo circadiano, especialmente estudiado en drosofilia. Cuénteme un poquito sobre su tema de investigación.
Sistema circadiano. Voy a mezclar inglés y castellano.
Yes, as you want.
Internal timekeeping system that's present in all animals, highly conserved from moscas to humanos, ser humanos, and is a clock which regulates almost all of our physiology, our biochemistry, our hormones, our behavior, brain, liver,
Wow.
kidney, really everything.
So, and you were obviously very involved to discover that, right? How was the beginning on this study?
So we were studying this problem and have continued to study this problem uniquely in fruit flies, in moscas. And so the three of us all worked only on Drosophila, which was shown many, many years ago to have a circadian clock. But nobody knew the mechanism or how it worked. And so we were working on this problem in fruit flies, made quite a bit of progress, and it turned out, not through our work, but the work of others, that the mechanism in mammals and humans was identical.
Right.
So in a way, our discoveries became important to the world because of this link, and all of life is connected, and this is one more example of this. And so the clock, the actual working, how it functions, is the same in humans and in fruit flies.
So the clock are in animals, this kind of biological clocks, but there is not only in the animal kingdom, but at the same time in the bacteria kingdom, right? In cyanobacteria was the first one?
In plants and in bacteria, and there's a fantastic clock that functions in cyanobacteria. It's a completely different mechanism from the clock that functions in animals. It's almost certainly the most ancient clock because cyanobacteria existed on the planet 2 billion years ago and are responsible for the oxygenation of the atmosphere, which had a very different composition. And that clock is composed of completely different proteins and functions in a completely different way, providing evidence that clocks probably arose multiple times on the planet. Once in cyanobacteria, again in the precursor of animals, and probably a third time in plants as well, each time independently.
But all of them with the same input, right?
The same input, which is light.
Right.
Because that has been the environmental signal which has been with us since the beginning of time. The rotation of the Earth with a circa approximately 24-hour time, which is in fact where the word circadian comes from. It means about a day.
Right, but now you know that there is not exactly 24 hours for all the clocks, right? And that you have different regulations and different behaviors, right?
Right. Humans have a timing of 24 hours and 15 minutes. Mice are a little bit less than 24 hours. Every animal has, every species is different from every other species, a little bit from 24.
But that it means as well that there is some connection, right? I mean, the planet is a unique planet. We are all just here, and perhaps we have this point in common, right? In certain point, in certain way.
So we all have our clocks, which are not very accurate 24-hour timers, entrained or reset every day by the very precise 24-hour light-dark cycle. And for humans, that entrenamiento tiene que pasar a través de los ojos.
O sea,
es la única
fotorreceptor
manera para pasar la luz
hacia los receptores que estarían en neuronas. O sea, el fotorreceptor, una traducción de señal a neuronas y ahí una regulación con neuropéptidos. ¿Cómo es ese mecanismo?
It's una conexión with glutamate, with the neurotransmitter glutamate at the end, al fin de axons from the retina hypothalamic tract to a little place in our hypothalamus in the brain, which is the central receiving location.
Are you able right now to explain why, different human beings have different responses on the same input, on the same light signal, and there are people that we love more nights, and people who loves more days.
Right. So we
right?
in English we call these early birds and night owls. People who wake up early and go to sleep early, and people who stay awake late and go to bed late. Actually, probably the difference is not in the response to the light signal. It's probably an intrinsic timing difference in those people where their clocks, the early bird's clocks run a little bit fast, and the night owl's clocks run a little bit slow.
It's like the calibration of our clocks.
It is simply as if you had a watch that runs fast and slow every day.
Right.
So it's reset every day, normally in both classes of people, which is why they're the same every day. But they're a little bit early or a little bit late every day the same.
Right. And how can you think these little clocks that we have around the body, because we have like internal regulations of different systems in our physiology, can impact in our health?
So what's been discovered in the last 15 years is the extent to which the entire genome, the human genome, the 23,000 genes that we contain, probably almost all of them are under circadian control somewhere. So this very simple clock present in all tissues is sitting on top of the entire genetic regulation in the body. It's different in each organ, what is regulated, but if you add up the genes that are regulated in all organs, it comes to almost 100% of the genetic constitution. And what that means is that the clock has its fingers in every aspect of our physiology. And so having healthy circadian function is probably very important for all aspects of human health.
Really, that it means that you're discovering, that your work is much important than you thought. You know what I mean?
It is much more important than we thought.
Yes.
We never imagined that it
it
would be so important, which is why I'm sitting here with you today, of course.
Yes.
It's called good luck.
Yeah, so tell me, how was the moment when you really received it at the first time, the notices? Yes. Where were you?
A la cama.
En la cama.
Estaba dormiendo.
¿A la noche o en...?
A las 5:10 de la mañana. It's always...
¿Cómo no entendí? ¿5 y 10 de la mañana? ¿Cómo?
5 y 10 de la mañana.
Ajá.
Y siempre, cada año, por todos los premios, es el mismo principio. En California, it's 2:10, a las 12:10. En Boston es a 5:10, siempre. ¿Y por qué la llamada llega 20 minutos antes de la conferencia de prensa
Wow. Qué
en
nervios.
Stockholm.
Sí, sí.
Porque no hay posibilidad de...
The filtration of the news. Okay,
leak.
okay. Yes, and did you expect that? I mean,
the call? No.
no.
course-
But
of course not.
I guess that there are several people involved in the promotion. I mean, to
Nomination.
the nomination.
Exactly.
Yes, and you don't know exactly.
No, you
or you know.
you sort
knew
of
it?
know that you've been nominated.
Okay.
Because people over the years will ask you for your curriculum vitae, or
Right.
they ask you a question
You're
about some
suspected
history,
something.
and so you have an idea that you've been nominated.
Uh-huh.
But there are many.
But then it's like 6 months to decide, kind of. Right?
Well, but they have nominated. It's 6 months. It's more.
More?
It's, let me think. The nomination is February 1st, so February to October. It's about 9 months.
Mm-hmm.
But the point is that many of these nominations are done every year, same nomination. The committee is sitting with, I would say, 50, not only 50 or 100 people, but they're sitting with 50 subjects, topics,
Yes.
sujetos diferentes.
Yes, it's very hard.
In CRISPR, genetic engineering.
Yes, very competitive subject as well,
But
right?
different, very different subjects.
yes.
So you have different people and different subjects. So the probability, even if you know you're nominated, the probability of success is very small.
So how did you feel?
Shocked and excited. Shocked and
Yeah.
excited. Also, you waking up from sleep. You're,
Yeah.
desorientado.
I'm very interested on who is behind the Nobel Prize. Can you tell me?
Who is behind the Nobel Prize? So in other words, who am I?
Right.
Right? So I think this is it's una pregunta bastante simple, pero una respuesta bastante complicada.
Esa es tu parte.
It's very hard to look back at one's own career and life and try and understand what things one did well. Things I've done badly is easier to find. So I'm very persistent. I do not give up easily, and so sometimes some pieces of this work took several years. We were struggling and luchando, and so we continued with that. A couple of times I made, I think, good choices scientifically of both the people and of paths, pasos, caminos a seguir, and where some experiments turned out to be important, and I had something to do with those. But also, in some cases, some of the important work was determined by the people in the lab. And they actually not only did the experiments, but actually decided to do those particular experiments. That was their idea. And if I have any credit there, it's to let them, you must let good people follow their own ideas. And the good people, when they have an idea, you let them go and try to stay out of their way, not interfere too much. So I think that mix turned out okay.
I think you enjoy to teach, right?
I do like to teach. It's a bit, being a showman, and I like people, and so it's fun to interact. Small family. I have one brother who's 4 years younger, and I was raised in Boston, and we had a family tragedy when I was 10 years old. My father died, and that left my mother in not very good shape, and having 2 small children to take care of, no money, quite complicated. And perhaps as a consequence, also, I suspect because of a little genetics. I was not a very good student, but I tested well, and so those tests that you have to take to get into university, I was very successful with those. And the combination of being a good but not outstanding student, plus the good testing, took me to a very good undergraduate university. And there I really fell in love with science and learned how to apply myself.
And you spent a lot of time at Brandeis University, right?
Right.
How was that? I mean, why? It's not very common, right, in the United States to be so long.
To stay one's whole career. So I've been 43
Wow.
years, almost 43 years at Brandeis. So I stayed there because I really like it. It's a small place. It's very interactive. I made good friends. When I say I made friends, I have friends in the athletic department. I have friends who are coaches, entrenadores de equipo de universidad, equipo de basket. And also, I must say that a couple of times I thought about leaving, of changing universities. And I have 2 daughters and a wife, so I'm the only man in our nuclear family. And the women in the house said, "No way, we're not leaving." So they, and that's a little too strong. My wife said, she said, "If you really think it's a better opportunity scientifically, we will consider it. But if you're thinking of moving just for a change, for novelty,
Right.
that's not a good enough reason to uproot the
It seems like
family."
it was a good advice.
Very good advice, and also, so the point is that strong women had a big influence on, and not just my wife, my daughters too. They said, "We like it here, we have our friends here, we do not want to move to another city." So, and then I took that seriously.
Tell me, what do you remember, the best part of your student life?
Student life, so I was, I went from Boston at 17 years old to California, to university, Caltech. And then I went back to Boston to do a PhD at MIT. And this was 1966 when I began at MIT, and I left in 71. And so those were the late 60s, los años 60. And so this was not only very interesting scientifically, and biology at MIT was very small in those days, very different than today. And so it was a wonderful, excellent, intimate department. And also the era was politically very engaging, because this was Vietnam, this was sex, drugs, and rock and roll. So this
All
was
happened in that decade.
all this stuff was happening, and
Yes.
and so it was, and I was 23, 4, 5, 6. So it was a great place to be, and you have some MIT connection yourself, and many decades later. But it was a very small place from a biology scientific standpoint, very different than today. Although Brandeis is 8 miles, 12 kilometers de MIT, and so I have good colleagues, good friends who are professors at MIT, and there's lots of exchange back and forth. Then I still have a warm place in my heart for MIT.
And how is the relation with young people in your lab? I mean, the young people, how is seeing you? I guess this is very important for doing a good team.
Yeah, so of course this has changed over the years. You have to, so when I began, I started at Brandeis, I started my lab when I was 30. In those days, in my peer group, everyone began at 30 in the United States. It was a very unusual time. It's very different today, as you will appreciate.
Right.
We grew up in the United States in post-war times. There's enormous economic expansion. The country and academics was expanding science because of Sputnik and the Cold War. And so there were jobs everywhere. You want a faculty job, you want to be a professor. If you could spell your name, you could get a job. So in general, it was very easy. It was very easy to get money from the NIH, get funding for your research. And so this was a golden era. And everyone went from university at 22 to a PhD at 27 to 3 years of postdoc and a job at 30. It was a uniform path. Nobody had money to travel. Nobody did anything but follow people who were interested in academics. There was no biotech industry, it didn't exist. So there were no other opportunities, there were no options. And of course, that in some ways, that's young people today benefit from having options. In another way, it makes life a little harder to decide what to do. So this was very straightforward and very easy. And at the beginning, my first students and postdocs, I was only a little older than they were. So you become your peers. You're almost the same. And then for maybe 10 years, it's like that. And then there starts to be a little bit of difference. Not so much for me, but for them. I go to the people in my lab today, and I go sometimes in the morning and I walk down there and say, hey, I read an interesting paper, or I had an idea. What do you think? So I want their input, just like they would come to me and ask me my opinion. So you try very hard to treat people as equals.
I think that I will enjoy if I had to work in your lab. Okay, it's not my subject, but well. So you're still young with a lot of energy. I can see you with a lot of passion in science. So I guess you have a lot of things to do, even if you just received your Nobel Prize. So what are your plans for the near future?
So I think it's very kind of you to call me young. I think that's...
You have a lot of years to do very nice things, right?
It's very generous. It's a complicated issue because I'm past the age where many people have retired by the time they reach my age.
But you have energy.
And
you are passionate.
I have energy, and I very much like what I do. And I've not found a good substitute for this. Is a little bit the issue with
or the lack.
Yeah, and I'm very lucky. I still have funding, and I'm well funded, and the prospect of my remaining well funded for a while, at least for a number of years, is good. So I think I'll probably continue to run a lab and continue to work on research. I'm very interested in sleep, which is a related subject to circadian rhythms. Why we sleep. It's not. I think the reason for sleep, the function of sleep, is not well understood. And I have hope that fruit flies, once again, moscas, otra vez, van a ganar, van a mostrar el pasillo.
Okay, so here are my last question. For young people, what kind of advices you have for them?
So I tell students the same thing I told my children, which is to try and find passion, something you really love, and then go for it. I think one, there are two problems, well, there are many problems, but two, in this context, two significant problems with youth, jóvenes. One is to discover what you really like, and number two, fear of failure, that is being afraid that if you put your whole self, 100% of yourself into something, you will fail. And of course, I think that's why young people often hold back. They only try 80%, because then when they fail, they can say, I didn't try 100%. And if you try 100% and fail, then you have really failed. But life is filled with failures. And so you're young only once, you find your passion, seguir sus estrellas, and do it. And there's time. If it doesn't work, if you want to be a ballet dancer or a violinist or a writer, you should try, and you give it 10 years, 5 years, 10 years, it doesn't succeed, you'll find something else to do to make a living. But at least you will not look back when you're my age and say, I didn't try. You want to try. And if science is what you love, you really should do it. It's a wonderful life.
Thank you so much, Professor, and obviously my warmest congratulations for your prize.
Thank you very much. It's a pleasure.